Hello to all the math students out there from Mrs. Marcellus and my very wise friend Euclid. In this lesson, we're going to learn to find the area of triangles. Today's learning objective is students will find the areas of triangles by creating models and applying a formula. Before we begin, let's review some key vocabulary. Area is the number of square units needed to cover a surface. In geometry, your answers must have a label. Units squared indicate area. Today we will be working with triangles. A triangle is a polygon with 3 sides. When working with triangles, it's really important to be able to identify the base and the height. The base is any side of the triangle, and the height connects the base to an opposite vertex. Next, let's take a look at deriving the formula to calculate the area of a triangle. Are you ready to tackle that, Euclid? He says he's ready, so let's move on. Now let's see if we can figure out how to calculate the area of this triangle. We could try counting up all the full squares, but we can see that we have a lot of partial pieces, and those partial pieces are a lot of different sizes, so that would probably be pretty hard to match up. And of course, we're not always going to have our figure drawn on a grid paper anyhow, so we need to figure out a formula. Well, a triangle does have a base and a height, just like the parallelogram, so that could be handy. And in fact, maybe we can base our formula off that of a parallelogram, which is area equals base times height. If we take our triangle and flip it upside down and add it onto the figure, it actually does form a parallelogram. This is super handy for us and really good news because every triangle is 1/2 of a parallelogram. If that's true, we know the area of every triangle would be 1/2 of the base times height. Another way we can think of calculating this is to multiply the base times height and then divide that by 2. Let's see how this works. Let's find the area of this triangle. If I wanted to, I could add another triangle of the same size and turn this into a parallelogram. And then I could see that overall in my parallelogram, I could find the area by multiplying the base times height. Since the triangle is half of that shape, I could then divide it by 2 to find the area of just the triangle part of the parallelogram. However, I'm probably not going to want to draw this every time, so I can simply apply my formula. The formula to find the area of a triangle is 1/2 times base times height. Or I can write base times height divided by 2. Either way will work. Now we can plug in our base and our height into the formula to calculate the area. Using the first version of the formula, I would write 1/2 times the base, which is 6, times the height, which is 8, and then I'll go ahead and solve. I can cross-cancel the 2 with either the 6 or the 8, and I'm going to choose the 6, and that leaves me with 3 times 8 equals 24. Another way to do the calculation using this formula is to change 1/2 into the decimal 0.5. Then you can multiply 0.5 times 6 times 8, and you will still get the same answer of 24. Using the second version of the formula, I would write 6 times 8 over 2. This gives me 48 divided by 2, which also equals 24. As you can see, there are several ways to approach this calculation. However, they do all give us the same end result. The area of the triangle is 24 meters squared. Don't forget, your answer must have a label to be complete. When you have an obtuse triangle, the height is generally drawn on the outside of the triangle because it's pretty much impossible to draw it on the inside. To find the area, we'll use our formula. As you saw in the previous example, there are multiple ways to complete this calculation. I'm going to show you using base times height divided by 2 because that's my favorite, but you should use whichever calculation method works best for you. The area would be 3 times 5, our base times the height, divided by 2. This gives us 15 divided by 2, or 7.5. The area of this triangle is 7.5 inches squared. Next, let's find the area of this right triangle. The base and the height are always perpendicular to each other and meet at a right angle. Since the leg that is 14 meters and the leg that is 9 meters meet at a right angle, we know these are the base and height. The measure of 16 6/10 is not included in our calculation. Then we will apply our formula. I plan to use base times height divided by 2, but you can also use 1/2 or 0.5 times the base times the height. To calculate the area, we'll multiply 14 times 9 and divide by 2. This will give us an answer of 63. The area of this triangle is 63 meters squared. A barn owl has a triangular-shaped ear that measures 14 millimeters at the base and 23 millimeters in height. What is the area of the owl's ear? Since we've been working with pictures all along, in this one we're just going to pick out the words and plug them into our formula. The problem tells us that the owl's ear measures 14 millimeters at the base and 23 millimeters in height. To calculate this, we're going to have to multiply 14 times 23 and divide that by 2. When we complete the calculation, we learn that the owl's ear has an area of 161 millimeters squared. Well, Euclid, it looks like you and the barn owl have very similar ears. I've always heard that owls have a very keen sense of hearing. I suppose that's why every time I go to have a snack, you hear it and you're right there wanting some from me, isn't it? Yeah, don't give me that innocent look. You and I both know better. Well, math students, this concludes finding the area of a triangle, so we're signing off for now.